So what are simple machines? So simple machines are defined as basic tools that will help us do work more easily. And by work, I mean just anything that's making us put in an effort, right? So today we're gonna investigate how simple machines will make that easier and reduce the effort or change the direction of the force we're applying. So there's six main categories of simple machines. There's the lever, the pulley, the wheel and axle, the incline plane, the wedge, and the screw. And in just a moment, we're going to go into what all of these are and some examples of them. But first, I just want you guys to look at an example right now and just tell me what you think is happening here. Right? How is one person able to lift the other? And have you used something like this before? Anyone can speak out.
Um, can I go?
Yeah.
Okay, so as I see, it's a seesaw, and I'm guessing it's because of someone's weight as you push up. So is it mechanical and gravitational from like kind of last week? I'm not sure what machine it is, like specifically what it would be called though.
Yeah, I mean, no worries. We can definitely see energy being used in this. They are pushing off each other or off the ground to get the other person like back to the ground. Have you used something like a ramp, scissors, or like a wheelbarrow? Did it make your task easier?
Yeah, it has.
Yeah, so that's all what simple machines do there. They're there for your convenience, if that makes sense. So right now we're gonna go into just those six main categories, right? So a lever is a bar that pivots around a fixed point called the fulcrum, or just the pivot. This would be the fixed point here. This is kind of like the seesaw that we just saw. And it's used to lift or move loads by applying a force on one end. So if we have a really big load or weight right here, and we want to get it high up, we can put a weight over here, make it like jump almost. Um, for example, a seesaw lets you lift a person by applying force on the opposite side. And this isn't just with a seesaw, think of scissors. They have this common pivot point where when you're pushing down on one of the handles, the razor goes up, and that way you can easily cut something, right? Or think of a bottle opener. As you're pushing up on one end, no, wait, you're pushing down on one end, the like rim of the bottle is getting pushed up by the bottle opener, making you be able to open that bottle easier, right? Um, so that's what a lever is. Next, we're going to go into pulleys. So a pulley is a wheel with a grooved rim, like right here, that helps lift or lower loads by changing the direction of force. So for example, maybe originally you thought of just carrying this block up, but when you use a pulley, you're changing it to where you're just pulling the rope down. Does that make sense? So I know we just went over some examples of levers and how you can kind of see them in everyday different things. Pulleys, for the most part, are pretty obvious when they're being used. You know, typically we can recognize this very easily. Um, but yeah, that's a pulley. And then there's wheel and axle. So wheel and axle is when a wheel is attached to a central rod, like this right here, that works together to move or lift loads with less force. For example, a wheelbarrow uses a wheel and axle to carry heavy loads easily over a distance. So for example, you guys see like furniture with wheels before? Have you guys seen that?
Yeah.
Yeah, so it's making that easier for you. That has a wheel and axle system in it. So think about it like this. If you're trying to move a really heavy box, there's all that friction at the bottom of the box between the box and the floor. Versus when you put a wheel and axle system, either you like put the box on it or you put wheels on the box or however you do it, that friction is being used as an advantage, right? Wheels are able to roll because they have friction. They're pushing off the ground. Um, so that's why wheels come in handy because they're using friction as an advantage for them rather than, you know, having the box pushing back on you with friction. We're halfway there, I believe. Next is an incline plane or like a ramp. So it's a slope surface that helps move heavy objects upward by reducing the effort needed. Have you guys ever tried to like carry something and it doesn't really work? So you have to like push it up along a ramp so that like it gets to point B, I guess, in a lower amount of time. I don't know if you guys have seen that. Anyone? I'm just gonna take that as a yes. For example, like a wheelchair ramp. You might have also seen elevators, but that's taking more for, well, not elevators, but like machines that lift people in wheelchairs like directly up, and that's using more force to get that person up versus like just going up a ramp. Oh, yes, Sarah?
I was gonna say I couldn't unmute myself last time, but when you were just talking about how they would bring people in wheelchairs up, I remember visiting a relative's house and they had this cool feature on their stairs that was like a ramp, and you sit down and it pulls you up the stairs.
Yeah, that's a great example. I was actually just thinking about that. That's a perfect example. It's bringing you up, and the reason it's doing that is because as when you have a ramp that isn't super not sleep, steep, there's a lesser component of gravity basically acting against the direction that you're trying to go. So think of it like this, like if you have a slide that goes like super, that's super steep, you're gonna get to the bottom probably faster versus you have one that's like slower and it's almost longer probably. It's gonna take you a little bit more to get to the bottom. Um, and that's just because it's less of a component of gravity acting against that direction. Um, so yes, we see this everywhere. Even at like a skateboard park. I also don't know if you guys have ever been, I don't imagine you guys drive, but maybe when your parents are driving, if you're going up a highway in Houston, because they're like super high, um, you might notice that the car starts slowing down and your parents have to press on the gas more because it takes more effort when you're going up. So that's a pretty common example of that. I think this is the second to last one, and this is a wedge. So a wedge is a simple machine that has one or two sloping sides used to split, cut, or push objects or materials apart. Um, so think of it like even if you're just trying to separate two people, have you guys ever seen someone trying to break up a fight and they like put both of their arms together and then like pull their arms apart so those people get pulled apart? That's the idea here. Um, but with objects. So think of it like an axe, right? These are two of the sloping sides. Kind of hard to show with this moving, but these are two of the sloping sides, and they'll push down on the wood with their common point, if that makes sense, that intersection. A knife is a very common form of a wedge. Um, that's why so easy. That's the probably the most common one we see. Um, yes. And I think this is the last one, a screw. So a screw is like an inclined plane wrapped around a cylinder that converts rotational force into linear motion. And it's usually used to hold objects together. So I know a lot of you guys think of screws and you think of automatically like these metal bits. Um, but we use screws in like everyday objects, especially when it comes to packaging, screwing a light bulb in or just closing a jar of peanut butter. Um, we see simple machines being used in everyday objects or even like a pencil cap, not a pencil cap, maybe like a pen cap, um, or like a marker. These things are made so that we can use these objects more efficiently and they can be stored more efficiently. Um, so I want you guys to kind of look at this problem, which is, I'm about to read it out. You need to lift a heavy box onto a high shelf. And I want you guys to think of what simple design you would use, right? So engineering is all about um, problem solving. So I want you guys to think about the six type of simple machines and which one or which combination of them you guys think will work best. And then I want you guys, I'm gonna give you guys like about maybe like 7 minutes, 5 minutes max. I don't know. I'll give you guys about 5 minutes to just think about that. And then at the end of it, I want you guys to describe how your design would reduce effort and solve the problem, right? Get the heavy box onto the high shelf. I'm gonna leave this up on the screen so that you guys can just like refer back to this whenever. Um, and then at the end of this, I hope you guys will be able to just say what you guys came up with. If you're a little shy, you don't want to say anything, that's fine. You guys can just type it in the chat once you think of your idea, and I'll be able to read it out once those 5 minutes are up. And your time starts now. All right, guys, it's been about 6 minutes. Not 6 minutes, 5 minutes. Would anyone like to share what they came up with? Sarah, what do you come up with?
I don't really 100% remember every slide, but I did think of a pulley system. Although I don't know how that would safely get the box onto the shelf, I do know that you could put the box into some sort of basket on one end, and instead of having to have all the weight, the pulley could help, and all you have to do is pull a rope. But I ran into a problem of thinking how will it insert the box into the shelf.
Yeah, I mean, the police system is a great idea. You were thinking right on track with that. A basket could work. The other thing would I just there are ways where you could like redirect the pulley. Maybe you could carry the box and then kind of move the pulley to where it's on top of the shelf and then lower it again, if that makes sense. Um, that's just how I would think about solving that problem. But I love the pulley system. That's an amazing example. And you guys will have homework on this like tonight. But I understand that this slide is kind of hard to remember. I'm teaching a little bit fast. I'm sorry about that. So I will be posting the PowerPoint and a submission for your homework tonight. Yeah, just by tonight. Would anyone else like to share anything? Like what they came up with? You guys can always say it in the chat. I think, oh, I think a lot of people just now joined. Okay, this lesson is recorded, guys. So if you missed the beginning of class, no worries about that. It will be posted, I believe, on YouTube. But stick around. This is a recap that I want to give. I did cut this lesson a little bit shorter because I understand we have some new people, and at the end of this, I want to make sure you guys are all on the Google Classroom. But just to recap, we want to remember that there are 6 types of simple machines. Um, there's the lever, the incline plane, the wheel and axle, the pulley, the screw, and the wedge. And each of these tools are designed to make work easier for you by either reducing the effort needed or changing the direction of the force or just increasing the efficiency, right?